Solution. The derivative of y with respect to x is given by the following expression. Taking the derivative of an integral is covered by the fundamental theorem of calculus, which states that, in simple words, the derivative of the integral of a function returns that function. Notice the change of variable from a dummy variable z to the upper limit of integration x. However, notice that the limits of integration are a constant and a variable, whereas in the given problem, the limits of integration are a constant and a function. Consequently, we cannot directly apply this theorem to be able to find the derivative. In this problem, we will apply the fundamental theorem of calculus with substitution. That is, we replace the function in the limit of integration with another variable. In the given problem, let u be equal to the square root of x. The problem now becomes the derivative of y with respect to u. Because the limits of integration are now a constant and a variable, we can now proceed with applying the fundamental theorem of calculus with substitution. Substitute u into f. The problem is now the derivative of y with respect to the new variable u. However, we are asked to find the derivative of y with respect to the original variable x. Hence, we use the chain rule. It states that the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x, where y is a function of u and u is a function of x. Substitute u equals the square root of x. And the first derivative of u with respect to x equals 1 over 2 times the square root of x. Simplify the answer. Express the radicals in terms of exponents. Use a property of radicals. Then, use properties of exponents to further simplify. Simplify the denominator. Finally, the derivative with respect to x of the integral from 0 to the square root of x of the square root of z times the inverse tangent of the square root of z dz is equal to the inverse tangent of the fourth root of x divided by 2 times the fourth root of x. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.